Hi everybody, and welcome to this very quick video tutorial about how to deal with perfect cubes and cube roots. This is standard EE2 for anybody who is looking to study for an assessment or a reassessment. This should be a short one, so stay tuned and hopefully this will help you out. Alrighty, if you watched the video on perfect squares, this probably looks a little bit familiar and you'll probably know where I'm going with this. You'll notice that I have the numbers 5 times 5 times 5, and it's used as a factor how many times? It's used 3 times. So we would call the 5 our base, and we're going to have an exponent of 3. And anytime we have an exponent of 3 or something raised to the third power, we call it cubed. So in each of these little problems, we have a number cubed. In this case, I have 3 times 3 times 3, which is 3 cubed, and 10 times 10 times 10, which is 10 cubed. Now, if we actually evaluate all those or work out what their value is, 5 cubed is going to be 125, and I get that by doing 5 times 5, which is 25, and then times 5 one more time. For the third time, that's 125. 3 cubed is 27. And 10 cubed is 1,000. And you should have a square chart and a cube chart from your teacher. If you don't, you'll want to either look one up or ask your teacher for another one. And we're going to be looking at the cubes, from 1 to 10. All right? Alright, so this should again look familiar. Looks a lot like those square root signs. And we actually are using the same symbol here. This little check mark with a tail, that's our radical still. But you'll notice that there's something that wasn't there when we were dealing with square roots. You'll notice this little number 3 here. And since we're talking about numbers raised to the third power, this 3 tells us which root we're taking. That number is called the index. And it becomes helpful because we can actually go beyond square roots and cube roots. We can go to a 4th, a 5th, a 6th root. And what we're looking at is basically what number is used as a factor this many times to make 125. And the 125 is called the radicand. Notice that's very similar to the radical. The radicand is the number underneath the radical. So we're looking for the number. I'm going to erase all this because it's a little confusing. That you multiply by itself 3 times, that you use as a factor 3 times to equal 125. Well, if you remember what we just looked at, the number that you use as a factor 3 times to get 125 is 5. The number that you use as a factor 3 times to get 27 is 3. And the number you use as a factor 3 times to get 1,000 is 10. Okay? I want to caution you that a lot of people get confused about this when they see this index here. They think that it's the same as when you did long division. They think it's 3 into 27. For some reason, it's the worst with numbers that are divisible by 3. This is not correct, okay? It's not 3 divided into 27. It is what number uses a factor 3 times makes 27. So that's got to be 3, because I can't tell you how many times I've graded a paper that says this equals 9. But 9 times 9 times 9 is not 27, okay? So just be very careful of that. That's just something to be aware of. The last thing I wanted to mention to you on this little slide is to notice that the symbol is gone. A lot of times I see students, when they've done their evaluation, they've evaluated the cube roots, they'll write it like this with the cube root sign still there. And their intention is good because they're trying to show that they did a cube root, but it's kind of like the cube root is an operation sign. So like when you do addition, let's say you do 2 plus 2 is 4, you don't usually write plus 4. Like you've done the addition, so you can get rid of it. Okay, same deal. If you did 4 squared, you would write that as 16 because 4 times 4 is 16. It's not 16 squared because that tells you still need to square something. So once you've evaluated those roots, you need to go ahead and get rid of the root sign. The cube root of 125 is regular old 5. Cube root of 27 is 3. Cube root of 1,000 is 10. If you write them still with that sign in there, you're saying now you need the cube root of 5, and you're looking for a small number that times itself 3 times makes 5. And so that's not what this is asking for. So just be cautious about that. All right. All right, the similarities to square roots don't just stop with the radical sign. A cube root is related to a side of a cube. And so we say that a cube root represents the side length of a cube that has a certain volume. Okay, so a cube, side of a cube with a certain volume. Just like squares had to do with area, because a square is a 2-dimensional figure that has area. A cube is a 3-dimensional figure that has volume. Draw my little nice little cube here. Okay, it has volume. It's three-dimensional. Okay, and cubes, think about three-dimensional. We have an exponent of 3, okay, because our units are going to be three-dimensional. We call these cubic units. Volume is measured in cubic units. Okay, even shapes that aren't cubes are measured in cubic units. Okay, so if we think about how we would find the volume of this nice little green cube here, we would do length times width times the height. Okay, 3 dimensions. And so we need to think about what would we multiply by itself 3 times in order to get 27. Well, we talked about this one on the last 2 slides. Hopefully you said right away that that's got to be 3 inches. All right, and if we multiply that 3 inches times 3 inches times 3 inches, it's going to give us 27 cubic inches. Okay? And so that's where our cube roots and our perfect cubes come from. This cube root shows, hey, well, how long would that side be if it was going to give you a cube with a volume of 27 cubic inches? All right, so I've got a word problem here that deals with an example of a perfect cube or cube root problem. I've got Tommy used wooden cubes. Go ahead and underline that key word there. He's using cubes to build a larger cube. He used 64 cubes to construct his cube. How many cubes high was his structure? I don't think I could have used cubes more times in that question. So when we think about this kind of question, just like with the squares, we have to remember what we know about cubes. So we need to imagine that Tommy has built this 3D structure. It's a terrible cube, I'm sorry. I'm not an artist, I'm a math teacher. That he's built this cube, and it's been built out of a bunch of little cubes. Okay, so if you can picture like those little cubes that you built with in kindergarten, stacking a bunch of them up to make a bigger cube. There's only certain ways that you could stack them and actually make a cube. Okay, if you stacked up, for instance, in my drawing, not a very good drawing, it's 3 cubes wide and 4 cubes high, at least on that front side. That's not going to make a cube because a cube has to have the same height, width, and length. Okay, so what I've drawn here is not going to be a cube. Okay, so we have to think about how Tommy could have stacked these. Well, here's the secret. It's that it's a cube root. Okay, so we have to think what times itself 3 times makes 64. Now, the thing with the cube roots is you kind of just have to memorize them. If you're in doubt, I always tell students you can make your own little chart, but what I need to know is that the volume is 64. So the side is going to be equal to the cube root of 64. And hopefully we've learned our cube roots. The cube root of 64 is 4. Okay, and I can test that out just to make sure if that makes sense. You could draw out what Tommy's thing looks like, or you could do math. Okay, if we do 4 times 4 times 4, 4 times 4 is 16, and 16 times 4 is 64. So I've proved that the cube root of 64 is in fact 4. Okay, so there's the answer to my question. I didn't do a perimeter question or anything on this. But if you're ever unsure, one thing I always tell students is if you haven't memorized all your cube roots and square roots and you're in doubt, you can always make yourself a quick chart or test it out. They're not magical. We get that the cube root of 64 is 4 because we proved that 4 times 4 times 4 is 64. So let's say you weren't sure and you thought maybe it was 6. Well, I could multiply out 6 times 6 times 6. Well, 6 times 6 is 36. Now, hopefully I'd figure out right away 36 times 6 is going to be way bigger than 64. If I wasn't sure, I could multiply it out. 6 times 6 is 36. 3 times 6 is 18, plus 3 is 21. So 6 cubed is 216. So I know that the cube root of 64 is definitely not 6. So if you're in a problem situation, you're taking a test or whatever, and you can't remember a cube root, please remember you can make your own chart really quickly. I say really quickly. You can take a few minutes and make your own little chart. All right? So hopefully this was a helpful video to you. That's about all there is to know about cube roots. Take that chart, make sure you've memorized it, and then just remember the big understanding is that a cube root represents the side of a cube with a specific volume. If you have any more questions, make sure you talk to your math teacher, and until next time, happy problem solving.